I'm Susie Mueller, and I'm a software engineer on the Go Tools team, and today I'm going to show you some tips for getting the most out of the editor. The Go community has written a lot of tools to help you build better projects, and these are available straight from your editor. Today I'm going to show you some tips for getting the most out of the VS Code Go extension. This extension is maintained by the Go team at Google and is open source. The extension is powered by a couple of tools, the Go language server, also known as Go Please, and the Go debugger, which is Delve. What's really great about these tools is that they implement the language server protocol and the debug adapter protocol respectively. And this means that these can be used from any editor that implements the LSP or DAP spec. And so all the features that I'm showing today, you could also access in Vim or Emacs or whatever your editor of choice is. And with that, let's hop straight into the demo. All right, I have VS Code open and the Go extension installed. And what we want to do is I have this file containing some text that I want to reverse. So what we're going to do is we're going to write a function that'll allow us to reverse the contents of this file, and then we're going to write some tests for that function and debug any errors that we encounter. And all while we're doing that, I'm going to be showcasing some different features that are available in the editor to make writing Go code easier. So the first thing I'm going to do is initialize my module by running go mod init. So I'm going to do this using a command provided by the extension. All I have to do is specify the name of my module. And a module is just a collection of packages that can be versioned together. And by running that command, it's created my go.mod file for me. So right now it just contains the name of my module and the version of Go that I am developing with. This is the file that will contain my dependencies, and I'm going to run go mod tidy, and this is going to add the dependencies that I already have in my project. So something in my project already depends on X tools, and I can actually check what it is by hovering over this require statement, and I can see that the doc package depends on the loader package from golang.org X tools. So some other code lenses have now appeared, and this allows me to keep my dependencies up to date so I can get the latest security fixes or features from the packages that I'm using. By clicking check for upgrades, I can do this individually per upgrade per module that I depend on. Now that we have our go.mod file all set up, we're ready to start writing some Go code. So I want to write this function near this other function that I know I already have in this workspace. So we've previously written some code that allows us to reverse the contents of a string. So I want to find where that is in my project, but I can't exactly remember where. So I'm going to use symbol search to search for the function. So this first result is in our string util package, and by opening it, it takes me right to that function. So I'm going to go ahead and start writing some Go code. So I'm going to start by writing out the function signature, and I'm going to accept the auto completions as they come up, and I'm going to fill in the return values. I want to return a string and an error, and that's it. So the first thing I want to do is read in a file. So I'm going to store the contents in this contents variable in the error, and I want to use this read file function from the OS package. I'm going to hit enter, and I'm getting signature help, which allows me to reference what the arguments are as I'm filling out my function. And since this function is from a different package, I have to include that in the import statement at the top of my file. Accepting the auto-completion automatically added that import for me, so I don't have to manually go ahead and do it. Now that I have this read file in my code, I can hover over it, see the documentation. I can click on this link to the package.go.dev website, which is a great place if you're looking for packages to include in your project. So if you didn't know that OS had this function, this would be a place to go to find which packages can improve your project. All right, and another thing that we see here before I continue is we have these red underlines under contents error in this last brace. And so these are compiler errors. So if I hover over them, I can see what they are. So I have the contents are declared but not used. So I have two variables that are unused, and I haven't added my return statement yet. And so these are both things that I'm planning on fixing. I just haven't finished this function, writing this function yet, so it's not going to build. So I'm just going to ignore those. The first thing I want to do after reading in that contents is to handle the error. So I'm actually going to do this by triggering a completion and then selecting this first completion item. So this is a common Go idiom where you check if the error is non-nil and then you return the error in default values for the rest. And with 2 keystrokes, I was able to handle the error. Now that I've done that really quickly, I will go ahead and reverse the content. So I'm going to return reverse, and so I've accepted that completion again, and I'm going to pass in contents. And I actually had tried to pass in contents, which was a byte slice, but reverse accepts a string. So the completion actually did the typecast for me, so I was passing in the right type. All right, so I finished writing that function, but I'm still getting this red line here. And when I hover over it, I see that I have the wrong number of return values. So this was the issue, is I want to return both a string and an error, but reverse only returns a string. So when I'm clicked on the line with this underline, I see this light bulb pop up, and in this description of the error, I also see this quick fix. So if I select the quick fix or the light bulb, what shows up is this code action. So this is to fill in the return values. So if I select it, it will attempt to fill in the return values with variables that are in scope and default values. All right, so now we're done writing this function. So I want to write some tests. So what I'm going to do to make this easier on myself is I'm going to use a function, a command provided by the extension to generate unit tests for this function. So I've done that, and now it's already generated all of this code for me. And this may be a lot to read right now, and you don't have to read it all, but the basics are that this code is a table-driven test. So we have these test cases defined by this struct type here, where we pass in the function arguments and then what we expect the results to be. And then the remainder of the code just runs the function that we're testing, and then checks that the results are what we're expected. So I'm going to delete this to do and add in a test case of my own. So my first test case, I'm about to start typing, but I see that I have this light bulb in the corner. So this means that there's a code action available, even though I don't have an error. So I'm going to trigger this from my keyboard, and I can see that the code action that's available is to fill the struct. So when I select that, it's going to fill in all the fields for me. So now I just have to fill in the values. So I'm going to go ahead and name the test case. I'll use the same code action to fill in args. Give the path to our hello.txt file. I'm going to put what we expect the result to be here, and that we don't expect there to be an error. Okay, so now we have our test case. Let's run this test. So above every test function, we have 2 code lenses to run the test and debug the test. And by selecting one, this will run the test and show us the output. So I'm going to expand this output view I can see pretty quickly that this test failed. Something went wrong. Not only did I get the incorrect value, this test panicked. So there was some kind of error that caused our program to panic. So I'm going to use the debugger to look into how that happened. Since I know that the program panicked, I'm not going to bother with setting any breakpoints. I'm just going to click debug test and let the debugger catch the program before it crashes so I can inspect the state at that point. All right, when I debugged the test, it opened this debug view on the left, which contains the variables that are in scope, as well as any variables that we want to watch, and a call stack, which has all of the Go routines that are running, including the one that is currently stopped, is labeled with the reason that it's stopped, so in this case, the panic. So I can look through and see all the stack frames. Additionally, when the program is paused on panic, we also get this exception info in the source code. So this is, you can readily see what happened, like what the error was that caused the program to panic, and as well as inspect the stack frame. So now I'm going to go back to the stack frame so we can pick the last frame that's in our code. So we have a couple of stack frames that are in the testing package, but I want to look at the ones that are in my module. So I'm going to go back here to the one that was in reverse and figure out what's going on. So it's this line 34. Now let's see what the variables were at this time. So our error said that we had an index of 12 that was out of range. And J is 12, so that looks pretty suspicious to me. And R is length 12. So if we tried to index into R with J, that would be an error. So now if I look at the code, I can see on the line before that J was initialized to the length of R. And so if we try to access that right after that, it's going to get an error. So there's just an off by 1 error here that I'm going to go ahead and quickly fix. So now that we've done that, I'm going to run the test again and inspect the output. So again, we're getting a test failure, but in this case, it didn't crash. This is a different issue than what we had before. So we're going to go ahead and debug this by setting some breakpoints and stepping through the program. So I'm going to start by setting some breakpoints. First, I want to set one here just at the start of this test. And I'll even make this a conditional breakpoint by editing the breakpoint and setting a condition for which it should stop. So in this case, I want it to only stop if the test case name is hello. And if I had many test cases, this could be really useful to get directly to the one that I want to debug. And then I also want to set a breakpoint in reverse. So I'm going to open this debug view actually and select this plus on the breakpoints section to add a function breakpoint. So now I can just type in the name of my function and it will set a breakpoint there. I could have also navigated to the source, but this is a way to easily do it without actually having to find the location of the function you want to break on. So now that I've done that, I'm going to go ahead and click debug test. So we're now stopped on our first breakpoint, which is here in our test function. So if we look at the variables, we can see that we are indeed on the test case that we wanted to be stepping through. The name is hello. This is the value we wanted out. We have the correct path to our file. Everything looks good. So now we're going to start stepping through the program. I can do this using the toolbar up here at the top. And so first I'm going to step into this function. So I'm going to step into reverse file. And I'm just going to keep clicking. And actually at this point, I'm in this read file function in the OS package. I don't really expect there to be bugs here. I feel like the problem is probably in my code, so I want to get back out to my code. So I'm going to step out and then just step to the next line. And I'm going to hit continue so that it will continue until it hits my next breakpoint, which is here in reverse. So now it's time to start actually looking at the values and see what went wrong. So I'm going to open up this debug view again and have the variables open. We have the argument, which is the hello world string, and then we have this variable r. If I expand it, I can see each of the individual values as well as a string representation of this slice. So in this case, we can see what all the values are, and we're just going to keep an eye on the string representation. So I'm going to start stepping through the program and see if we can figure out what's going wrong. And pretty quickly, I'm seeing that the end of the string is being copied to the beginning, but the beginning's not being copied to the end. Line 34 was supposed to be swapping these, and clearly it's not doing that. So this is a bug. We can fix this right here by just making this change. One thing we notice here is that what popped up is this yellow underline. And what this is, it's not something that's going to break your program. Your program is still going to build. It's detected that there's likely a bug. So in this case, that RJ is being assigned to itself, which we have this RJ is being assigned. This RJ is being assigned to this RJ. So when we complete this line so that we have the correct swap, that warning goes away. And we've, I believe, fixed our function. So I'm going to run the last test that we tested using a command, and it passed. Great. Now that I've made sure our test passed, I want to make sure that the tests I wrote were actually good. Did they actually cover what I wanted them to? So I'm going to toggle test coverage in this package. And what that is going to do is it's going to, first of all, run this command and print the output. So it's going to test all the tests in this package, run all the tests in this package, and then say whether they passed or not, and also the percentage of statements that were covered. So this is every line that was hit at least once. I kind of want to look more in detail about what is actually covered. So if I go back to my source code, I can see that the lines that are in green were lines that were covered by a test, and lines that are in red were not. So in this case, I might want to add a test that covers this case where the error is non-nil. Now that I finished writing this function and testing it, I could go back and refactor code that I've already written using other features available through the extension. To see a complete list of features, you can check out our VS Code Go documentations to see all the extension has to offer for language features, testing, and debugging.